Stoichiometry. Let's see one real example like formation of water 2H2 plus O2. Formation of water takes place. Here in this balanced chemical equation, by mass, with respect to mass, we can say that 2 into 2, that is 4 gram of hydrogen, reacts with 2 into 16, that is 32 gram of oxygen, and gives 2 into 18, that is 36 gram of water by mass. But if the same equation we discuss on the basis of by moles, number of moles, then we can say this is the first one. Now in second case, on the basis of moles, we can say that 2 moles of hydrogen combined with 1 mole of oxygen and gives 2 moles of water. If the same equation we discussed on the basis of number of molecules, so we can say that 2 into 6.022 into 10 to the power 23 molecules of hydrogen reacts with 6.022 into 10 to the power 23 molecules of oxygen. Avogadro number. We have discussed already in mole concept that 1 moles of a substance contains Avogadro number of molecules, atoms, ions, etc. that are present in the category as per the category of the substance. Now here 2 into 6.022 into 10 to the power 23 molecules on the basis of molecules. We have discussed on the basis of mass, on the basis of moles, on the basis of number of molecules. Now on the basis of volume. Next category. So on the basis of volume, we know at NTP the 1 mole of matter occupies 22.4 liter. So here we can say that 2 into 22.4 liter of hydrogen combines with 22.4 liter of oxygen and results 2 into 22.4 liter of water. So, what is stoichiometry? Stoichiometry is the quantitative relationship between reactants and products in a balanced chemical reaction. What is the definition of stoichiometry? It is the quantitative relationship between reactants and products in a balanced chemical equation where the relationship may be established with mass to mass, or moles to moles, or molecules to molecules, or volume to volume, or mass to volume, or number of particles to moles, and so on. These all are the category of amounts, whether in the form of mass, or in the form of moles, or volume, or number of molecules. So, the definition of stoichiometry is it is the relationship quantitatively between the reactants and the products by mass, by mole, by molecule, or by the number of molecules. If we see a balanced chemical equation like we have discussed already here 2H2 plus O2 formation of water, we see some numbers before the reactants and products. Since the given reaction is a balanced chemical equation related with preparation of water, synthesis of water from combination of hydrogen and oxygen, Here the values before the reacting species and products represents about the whole number, and this whole number is called stoichiometric coefficient. So what are stoichiometric coefficients? The whole numbers placed before the reactants and products in a balanced chemical equation represents stoichiometric coefficients, and with the help of these coefficients we can calculate the actual amount of reactant and product. So quantitative analysis of reactants and products can be find out with the help of stoichiometric coefficients. We can measure the amount used and the amount of the product formed. This stoichiometry is a Greek word actually. Greek word, and has derived from stoichion, that is element, and metron, that is measurement. So we can say that it's a type of measurement of the amount of the reactants and the products in a balanced chemical equation. Let's see another example related to preparation of ammonia by Haber method, and we will establish a quantitative relationship between reactants and products with the help of balanced chemical reaction. N2 plus 3H2 and gives 2NH3. It's a balanced chemical reaction where 3, 2 and 1 before nitrogen represents about stoichiometric coefficients. On the basis of mass, we can say that 2 into 14, since we know nitrogen atomic mass is 14, hydrogen is 1. Therefore, 28 gram of nitrogen reacts with 3 into 2, 6 gram of hydrogen and gives 2 into 14 plus 3, that is 34 gram of ammonia. On the basis of mass, that is mass to mass relationship between reactants and product, 28 gram of dinitrogen combines with 6 gram of hydrogen and gives 34 gram of ammonia. If the same we consider on the basis of moles, then we can say this is first, now second on the basis of moles. 1 mole of dinitrogen combines with 3 moles of hydrogen and gives 2 moles of ammonia. If the same relation we establish on the basis of volume, so we can say that 22.4 liter of dinitrogen. Why this 22.4? At NTP, each substance, if it contains 1 mole, will occupy 22.4 liter space. Now here 3 into 22.4 liter of hydrogen, that gives 2 into 22.4 liter of ammonia. On the basis of number of molecules, we can say that Na, Avogadro number of molecules of dinitrogen reacts with 3 into Avogadro number of molecules of hydrogen and gives 2 into Avogadro number of molecules of ammonia. So here this balanced chemical reaction establishes quantitative relationship by mass, by moles, by volume, by number of molecules and also from mass to moles, moles to volume, volume to mass. In different types we can find out the amount of the reactant used and the product formed. So this is all about the stoichiometry and stoichiometric coefficients.